y'all. This is lesson 12.3. We're going to talk today about three variable systems. When we are looking at three variable systems, there's a couple things that we want you to be able to do. First of all, you should be able to solve a system in three variables. We've been doing two variables so far. Now we're going to do three. You also need to validate the solution of the system. Don't forget to check your answer. And last, the answer should always be written as an ordered triple. We're going to talk about what that means and how to write that. So a couple things to talk about here. The graph of a three variable equation is a plane. So when you're graphing something in three variables, it's a plane. And if you kind of think about a plane as a piece of paper, that's kind of the easiest way to think about it, okay? Planes can intersect in different ways. First off, they can intersect at one point. That is most of what, in fact, pretty much all of what we're going to be doing with our three variable systems is finding the ones that intersect at one point. They can intersect at a line. They can intersect each one separately, or they can intersect not at all. So again, there's several different ways that planes can intersect. We are going to focus mostly on number one here, where they intersect at one point. Like I said, that's what we're going to focus. The solution to that is called an ordered triple, okay? That point where they intersect has three values that position it, an x, a y, and a z, and they're put in alphabetical order, okay? So an ordered triple could be at 1, 3, -4. That would mean that x was 1, y was 3, and z was -4. So we're going to be writing our solution as an ordered triple, and it should be in order, x, then y, then z. Please make sure that you are cognizant of that, okay? The first method that we're going to use, that we're going to go over, is substitution. And you can see here I've kind of got the beginnings of substitution. What I did is I took this first equation, and I manipulated it so that it's z equals. You can see that I subtracted the x to the other side, I subtracted the 2y to the other side, and I arrived at z equals 10 minus x minus 2y, which I then substituted in for z in the other two equations. So I'm just going to label these the A equation, the B equation, and the C equation. I took my A equation and manipulated it. I plugged it into the B equation, and I plugged it into the C equation. That's what substitution is, okay? So let's work through this. Again, this is the same problem. I've got this first equation manipulated so that it's z equals, and I'm going to plug that into the other two equations. So I'm going to start with 2x minus y plus 3 times. Now remember, I'm replacing the z with what z is equal to. And then that's equal to -5. Okay, so I'm going to simplify this equation. I am not going to solve this equation, okay? At the end of this part right here, I'm going to have another equation with an x and a y. But what I've done is I've gotten rid of the z. I'm down to two variables, okay? So I'm going to start by distributing the 3 that's in front of the parentheses. And I'm going to distribute that to all three things, the 10, the x, and the 2y. And I'm going to pay attention to the signs. So 3 times 10 is plus 30. 3 times -x is -3x, or minus 3x. And 3 times -2y is -6y. Now I'm going to combine my terms. I'm going to get my x's and y's on the left and my constants on the right. So I'm going to combine the 2x and the -3x, which is -x. I'm going to combine the -y and the -6y, which is -7y. And at the same time, I'm going to subtract 30, so it moves to the other side. And I'm going to get -35, okay? Now, I'm going to put a pin in that. I'm going to come back to this equation, but for right now, it's as simplified as it can get. I'm going to go back to my original, and I'm going to substitute the z in the third equation for what it's equal to. So I'm kind of doing the same thing again, but now with the third equation. So I'm going to replace the z with the 10 minus x minus 2y. And I'm going to simplify again. Notice I'm not solving, I am simplifying. So I'm going to start by distributing the 5. And remember that it's a -5 that I'm distributing. So -5 times 10 is -50. -5 times -x is plus 5x. And then plus 2y. Now, once again, I'm going to combine like terms. So I've got 2x plus 5x is 7x. Negative 3y plus 10y is 7y. And I'm going to add 50 to the other side, and I get 52. Okay? So now I have two equations that are x and y equations. I'm just going to rewrite these next to each other because this is what we've been solving. We've been solving systems with two variables. So now I can go ahead and I can use either substitution or elimination to solve these two. I can very clearly see that elimination is a pretty easy idea here because negative 7y plus 7y is going to cancel. So I'm going to add the negative x plus the 7x. And I'm going to add the negative 35 plus the 52, which is 17. And then I'm going to solve. Okay, so let's look at this a second. Something went wrong here, okay? I've got a 6x equals 17, and that's kind of ugly. Not that that's not valid, but I wrote these problems, and I don't remember them being that ugly. So I'm going to look back, and I notice that in this equation here, I dropped on the 2 and not the 27. So let me fix this equation, and that's going to change this here. So 27 plus 50 is 77. Now I'm going to add the negative 35 plus 77, which gives me 42. And then I'm going to solve by dividing by 6, and I get x equals 7. It's a really good idea to kind of stop and check yourself with these problems because there is a lot of work here, and it's very easy to make a silly mistake like I did. I just didn't write a 7. But it can mess up the whole problem, and you don't want to have to go back and redo the whole problem. So kind of give yourself little stop and checks. Just to make sure that you're like writing stuff correctly, that you're doing the right sign, and that you're kind of progressing like you need to, okay? So now that I've got x, I want to find my next variable, which in this case is going to be y. I'm going to take this x value and I'm going to plug it back into one of my two simplified equations, okay? And I'm going to pick the top one. I don't really have a reason for that other than I usually like to plug in the top and check in the bottom. So I'm going to put 7 in for x. So I've got negative 7 minus 7y equals 35. I'm going to add 7 to the other side, and I'm going to divide by negative 7, which is negative 6. Now, it's a really good idea to stop and check that in the other manipulated or simplified equation, okay? So if I plug 7 in for x, and I put 6 in for y, I should get 77, negative 6, sorry. So let's check this and see, okay? So 7 times 7 is 49, minus 42 is not 77. So something didn't go right here. Again, oh my goodness, I'm messing up my signs today. This was a negative 35. So let's fix this. When I add 7 to that, whoops, I get negative 28 divided by negative 7 is 4. Let's try this again. So 7 times 7 is 49 plus 28 should be 77, and it is. Now I'm okay. So let me go back to my ordered triple here. I know the x, I know the y. Now I want to find the z. I'm going to go back to my manipulated equation, and I'm going to plug both my x and my y into that one to get my z, okay? So I'm going to take 10 minus x, which is 7, minus 2y, and y is 4, and I'm going to see what I get for z when I do that. So I have 10 minus 7 is 3, minus 8 is negative 5. Now here's where it's so important. You have to check this ordered triple in the other equations, okay? So I plugged into the top, so I'm going to check 7, 4, and negative 5 in the other two equations. So I'm going to take 2 times 7 is 14, minus 4, plus 3 times negative 5, and I get negative 5. So it checks in the second equation. Now I'm going to check the third one. 2 times 7 is 14, minus 3 times 4 is 12, plus 5, minus 5 times negative 5 is plus 25, and I get 27. So 7, 4, 5, or negative 5, I have validated that solution. and I'm ready to move on. But that was kind of a doozy, huh? There's a lot of work here with these problems, and it's really important to pay attention to details and watch your signs. Make sure you can write numbers correctly if you're me, or just kind of pay attention to what you're doing, okay? Let's try another one. This time we're going to work through the method of elimination. That's our other algebraic method. And you can see here what I've done is I've gotten equations to be the same so that I can eliminate them, okay? So I decided I wanted to eliminate z. So I multiplied this top equation first by 3 to make the z the same as the second one. And then I multiplied it by 5 to make z the same as the third. So you can see that now I have a 3z and a 3z, and I'm eliminating. And down here I have 5z and 5z, and I'm 5z and 5z, and I'm eliminating, okay? So let's walk through this one. So here's my work that I did so far. This was from the last page. The z's are the same. Notice I'm subtracting, okay? How do I know I subtract? Because same signs subtract, which means that I'm subtracting all the other stuff. 3 minus 2, 6 minus negative 1, and 30 minus negative 5, okay? And then on the bottom one, I multiplied that top equation by a 5 to get 5z the same, and I'm going to add this time. I'm going to add because my signs are different. Okay, so same signs subtract, different sides add. So I'm going to add 5 plus 2 to get 7x, 10 plus negative 3 to get 7y, and 50 plus 27 to get 77. Hey, these should look familiar. Okay, this is the same problem that we just did with substitution. Now we're doing it with elimination. And notice that with elimination, we got the same two equations that we had on the last one. Okay, so we can go through all the steps again and simplify or combine. So I'm going to say x plus 7y equals 35, 7x plus 7y equals 77. I'm going to subtract these because 7y minus 7y is what cancels, and x minus 7x is negative 6x, and 35 minus 77 is negative 42. Divide that and I get x equals 7, which if you remember was the correct answer for x on our last one. Then we would want to plug this back in for x into one of the two equations and solve for y, and then put those back into one of the equations up here to solve for z. I'm not going to show you all that because it's exactly the same as what we did on the last one, okay? So you can choose to either solve with substitution or elimination. Either one will get you to the exact same spot, okay? Let's try another one here. This one's a little different because we have some smaller equations that we want to manipulate, okay? So I'm looking at this, and I see that the top equation has an x and the bottom equation has an x, and I'm thinking, what if I were to eliminate those x's because they are the same, okay? So I'm going to take the top equation, the x plus 2y equals 12, and I'm going to combine it with the bottom equation, x plus, I guess I should have left a space here. Let me try this again. X plus 6y plus z equals 20. So since I didn't have a z in the first equation, I'm just going to leave a blank spot for it. And when I'm adding or subtracting these, I just won't do anything with the z, okay? Which, in fact, I'm going to be subtracting because x minus x is 0. And I'm going to take 2y minus 6y, which is negative 4y. Nothing minus z is minus z. And 12 minus 20 is negative 8. Now, this is a YZ equation. I also have a YZ equation at the top, okay? So I'm just going to bring that one down. There's nothing that I need to do with it because it's already had the X eliminated. So I can just work with the YZ thing, okay? So now here's where I want to get either the Y's or the Z's to be the same, and I want to cancel those out. And it's up to you what you do. I'm going to multiply the top one by 4 just because it looks like that might be a nice, easy way to go. I could have multiplied the top one by 3 and the bottom one by 4 to get the Y's the same. It doesn't matter. But my signs are different, so I'm going to subtract. okay, because negative 4z minus negative 4z is 0, which means I'm going to subtract everything else. 3 minus negative 16 is 19y, and 25 minus negative 32 is 57. And 57 divided by 19 is 3. So this time, in my ordered triple, I've got the y value, and now I need to go back and find x and z. So I'm going to look back up here to this 3y minus 4z equation, and if I put in 3 for y, I can solve for z, okay? So 3 times 3 is 9, minus 4z equals 25, subtract 9, and divide by 4. So now I know that z equals negative 4. Looking at the top equation, if I plug in a y there, I can get x. Because I know that x plus 2 times y is 12. And I can solve this out, okay? And I get x equals 6. So then all that's left for me to do is just check my answers. And since I plugged into the top and the middle, all I really need to do is check it in the bottom. So hopefully 6 plus 6 times 3 plus negative 4 gives me 20, and it does. So 6, 3, negative 4 is my ordered triple and the solution of my system. All right, so we've got another one here. I am going to tell you, to be honest, it doesn't matter whether you do substitution or elimination, okay? First, do whatever feels most comfortable for you. If you feel really good about substitution, like I got this, substitute. If you feel better about elimination, it makes more sense to you, go elimination, okay? There's really no right or wrong for these problems. They're going to be kind of complicated and tedious. So pick the method that works best for you so you don't make a mistake and have to go back and redo the problem again, okay? So I'm looking at this, and since we did the last one with elimination, I'm going to do it with substitution just so I can give you a good example of what that looks like, okay? So I'm actually going to add y to the other side and subtract 13. So I get y equals 4x plus 5z, whoops, minus 13. Now this is what I'm going to plug in for y in both of the other equations. So I'm going to start by plugging it into the top equation for the y with the 3, okay? So I've got 2x plus 3 times 4x plus 5z minus 13 minus 4z equals 20. And then I'm going to distribute the 3. I'm going to combine like terms. 14x and 11z. And I'm going to add that 39 to the other side, okay? You're going to get maybe some big numbers or different numbers. That's okay. Don't freak out, all right? 59, yeah, is a pretty big number, but that's okay. We can work with it. Now I'm going to take my y value and I'm going to plug it into the bottom one. So this time I'm going to multiply 2 times what y is, 4x plus 5z minus 13. I'm going to distribute the 2. And I'm going to combine like terms. And I get 11x plus 14z, oh that's weird, equals 15 plus 26, which is 41. Weird because it's not very often that the variables would work out like that where they're almost exactly the same, okay? So I have two equations now. I have 14x plus 11z equals 59. And I have 11x plus 14z equals 41. I need to solve this system for either x or z, and it doesn't matter. Again, pick one, okay? So I'm going to pick z to eliminate, which means that I need to get my z's to be the same. Remember that the easiest way to do this is really just to multiply the equation by what the other coefficient is. So I'm going to multiply the top equation by 14 because that will give my z's the same, and I'm going to multiply the bottom equation by 11 because that will also give me the same z's, okay? So 14 times 14x is 196, plus 11 times 14 is 154. And 59 times 14 is 826. Now I'm going to do the bottom one, multiply by 11. So 121x, 154y, and 41 times 11 is 451. I'm going to subtract the two equations because my y's have the same sign. Remember, same signs subtract, which means I'm going to subtract everything else. So 196 minus 121 is 75x, and 826 minus 451 is 375. I'm going to divide 375 by 75, and I'm going to get 5. So in my ordered triple, I have found my x value. Now I want to find my y and my z, okay? So I'm going to go back one step, and I'm going to look at this 14x plus 11z, and I am going to plug my 5 in, and I'm going to solve there. So I'm going to take 14 times 5 plus 11z equals 59, and I'm going to solve this. This is 70. We want to subtract 70, and we get negative 11, which means that z is equal to negative 1, okay? Now, real quick, I just want to check that in this other equation just to make sure. So I'm going to multiply 11 times 5 plus 14 times negative 1, add them together, and I do get 41. It's always a really good idea to just stop and check yourself there and make sure that both of your answers are correct, okay? Now that I've got x and z, I'm going to put them back into my y equals equation, and I'm going to solve for y. So 4 times x plus 5 times z minus 13, and that will give me my y value. So 20 minus 5 minus 13 is 2. And then I want to check it in the other two, okay? So we're just going to plug in 5 for x, 2 for y, negative 1 for z, and see if we get 20. 2 times 5 is 10, 3 times 2 is 6, and 1 times negative 4 is 4, and we add those together and we get 20. So it checks there. I'm going to try the bottom one, 3 times 5 plus 2 times 2 plus 4 times negative 1 is 15. So again, just take the time to check your answer and make sure that you didn't do all that work for nothing, okay? Please remember, guys, you're going to make mistakes on this, and that is okay, as long as you're trying. Trying is the operative word here. Take a step, okay? Try something. It's okay if it's not the right something. You can learn. Make a mistake and go, oh, that didn't work, but I found out something. I can try this. I can try that, okay? So please always try. If you need help or you have questions or you're not sure what to try or you're not sure why it didn't work, please ask us. We are more than happy to help, okay? So this video is all about 3 variable systems. You are solving them. You are finding your ordered triple. And as always, this lesson has been brought to you by Conalonzo Inc., okay? Take care, do your best, and solve those systems.